Good morning, everyone. Welcome to HULFT's Digital Transformation webinar series. Today, this session is on unlocking the value of your legacy infrastructure. My name is Kurt Fuller, and I'll be your moderator today. Our presenter is Dimitri Dukan, who is head of digital manufacturing at HULFT based in Detroit. Dimitri has more than two decades of enterprise software experience. He's worked for Pivotal, he's worked for Cisco, and he's been at the forefront of bringing the latest technologies to supply chain and manufacturing companies. But as we all know, in this industry, the latest technology means nothing if it's not seamlessly integrated with your core infrastructure. And that means legacy. Dimitri, based in Detroit, in one of the most established technology industries in the world, which began with auto, he spent a lot of time working with integrating legacy and the most modern systems and everything that an enterprise could possibly have. He's built a career-long specialty at this, and that's why he's with us today. So this session is going to be 30 minutes today. Switch a slide here. And we hope to make this as interactive as possible. So please submit your questions by going to the Q&A button at the bottom bar of your Zoom window, and we will pick them up and we will handle most of them at the end of the session. And if something comes up that I need to interrupt Dimitri with, I certainly will. And then finally, we will record this session. So we will make it available to you after this event today so you can share it with your colleagues. So now I'll hand it over to Dimitri. And let's start with the first question, which is, what is legacy? It has such a kitchen sink meaning sometimes. I think we should refine it.
Thanks, Kurt. Thanks for having me on. Folks, thanks for joining. Really appreciate it. So what is legacy? I hate the term legacy because to me, it's used almost as an excuse. Legacy is the operation of any computer system that does not have the connectivity to interoperate with today's environment. The fact that it does not have that ability is only because somebody didn't put that ability in. We and others can absolutely put that ability back in, and the legacy can go away. Mainframe servers, non-conforming operating systems are all what people consider legacy. Again, none of that is really true. Operational technology such as PLC, warehouse management systems, manufacturing execution systems, yard management systems, scanners, there's multitudes of different electronic devices that people consider legacy, and because of that, make the excuse of why they're no longer useful. Again, none of that is real. None of that is reality. So let's talk a little bit about legacy, pros and cons. So the first part of it, these are systems that are established and very reliable. Most of them have been in use 20 years, 15 years. So obviously something was done right. They've supported the business through thick and thin for a long time. Most are well paid for and well built to understand the changes and nuances in the business dynamic. There's deep institutional knowledge buried in these systems, some of which may no longer exist in human form on-prem. So again, there are some drawbacks. They're difficult to interconnect with. They're difficult to interconnect with because they were built on different constructs. They were built with different ideas about what connectivity should be like in the future or at that time. There more than likely is a higher cost of maintenance. However, the rip and replace is really expensive. Retiring institutional knowledge can be a benefit and a burden. In the case that it's written here, retiring institutional knowledge is the knowledge necessary to keep a legacy system afloat. However, lots of that institutional business knowledge and operational knowledge is also buried in the system.
Hey, Dimitri, what would you say to somebody who's a more modern architect or whatever inside of an organization who says rip and replace is the only way to go?
So rip and replace being the only way to go, to me, is fraught with incredible peril. In that architect is looking at it from a systems perspective. They're not looking at it from the perspective of the business. There is a lot of business knowledge, which chances are they're not going to get back. And so to me, instead of a rip and replace, I would advocate for an approach that connects the legacy to modern and does a very gradual approach of information sharing between the two systems towards the business. And then once the information and real knowledge is inside of the more updated system, then the legacy can be retired. But always making sure that the intellectual property that drives the business is safely ported to modern.
Got it. So let's talk about how. What are the steps?
So absolutely. So first, the real thing to do is identify the problem. A lot of people want to rip and replace because there's a service contract that's all of a sudden exploded to being double what it used to be. Well, maybe so. However, if that contract is all that's driving you, what is the value of lost data? So let's identify the problem to be resolved. What is the required data? Is it just a database that's maybe easy to pump out with a few SQL statements, or is there a lot more to it? Who are the data owners? If it's a business organization, if it's sales, if it's manufacturing, if it's warehousing, supply chain, whoever those folks are, you want them on board working with you because they'll direct you as to what's important today. Lastly, what is the schema? So somebody should draw up some sort of a blueprint of 50,000 foot view of all the data, what's necessary, or at least what's known, and how you're going to try to move that over so that everybody has the same roadmap. You map the solution. You define the scope of work. This one's my personal pet peeve in that this one always seems to creep and crawl for reasons or whatever. Identify third-party software and service requirements. This is important because if somebody helped generate the different intellectual property, you want to definitely make sure that that's ported over. That third party may no longer exist. Define the proof of concept. This is key because this is going to be your first time that you can check value. And time to value is critical. And then the stakeholders that you identified in the first part of who owns the data, make sure their buy-in is there. Make sure they're part of the proof of concept. Make sure that when that proof of concept is considered successful or unsuccessful, that they're the ones helping you make that decision. And if it's unsuccessful, that they're the ones helping you repair. Now, work in an agile 2-week sprint manner, demo. The reason I say this is I've seen too many of these projects where the engineers are heads down, they're working really hard, they've interpreted what the business said, and 6 months later, they turn something around and it's nothing of what the business wanted. Maybe what the business said, but it's nothing of what they wanted. And so now there's a lot of time wasted, there's a lot of money wasted, everything else. If, however, your very first proof of concept is nothing more than the rows and columns of the schema, is the architecture of the data at a 100,000 foot view, and the business says, well, there's a start, and then you start populating, then you start making formulation, then you start writing code. Now the business is with you every step of the way. They're directing the changes. At most, you'll lose 2 weeks worth of effort. 2 weeks worth of effort's a lot cheaper than 6 months worth of effort. and a lot easier to pivot from. That's the last part. Pivot quickly towards the value. The fact that somebody misinterpreted a story, somebody pushed something out that the business says, this is not at all what I wanted, shouldn't be taken personally. There's a miscommunication, and when that miscommunication is 2 weeks, that's okay. Nothing to it. You simply say, okay, now I have a better idea of what you wanted. Now we both have an example in front of us. Let me pivot quickly. I'll demo again in another 2 weeks or hopefully sooner. And now we can make sure that the real value you wanted is captured, and we pivoted right to that value.
Yeah, Agile seems to make a lot of sense. Let's move into case studies. You've got a couple to share here.
Excellent. Yeah, so this one's my personal favorite. This one's my personal favorite because we were invited by Toyota and suppliers to see what we could do. They were using Motorola scanners. These Motorola scanners had Windows CE5 on them. And if you know anything about the Windows mobile operating system, you know that no longer exists. So that's first and foremost. CE5 hadn't been seen in well over a decade.
What is CE5?
So it's Windows mobile operating system for Windows devices. It was the operating system used on the scanner, and it was in the first 5 revisions of Windows having a mobile operating system. So this thing was old. So they started asking if we could enable these scanners, and the reason they started asking this question is it turns out these scanners, even to replace today, are several $1,000s a scanner, and they had in the neighborhood of 10,000 of them. So just replacing them function for function before you had any extra value was going to be millions of dollars. And new training, new testing, new operational procedures. You're looking at several years, and Toyota didn't have that. So they said, could you enable these systems to speak to us in a modern RESTful, so a modern cloud API way? So we said, I don't know, these things are kind of old, but let us give it a shot. What we discovered is with what was on that operating system, there was the basics of HTML. So we very quickly could write a module that whatever the scanner saw, whatever the scanner did, it would wrap that into HTML and it would send it to one of our servers. From there, we could maneuver it, manipulate it in a very modern way. We could do the exact same thing that all modern developers, whether you're at Amazon or Facebook, it doesn't matter. We could get this data off of this, circa 2001 scanner. We can get that data to you no matter what you were a part of. From that, they said, you can do this. All righty, we got a better one for you. We've got 60 plus AS400s, old mainframe or old mini frames as they were called, servers. Can you do something with these? But, sure, absolutely. Turns out that one's actually even easier because they have the fundamentals of SQL. So we could speak to them in a relatively still modern, very useful way of talking database to database. We very quickly used our SQL connector, connected that to our Amazon connector, and built a bridge that from which we could then make a modern API for an AS400. I still tell people that we built a modern RESTful API for an AS400, and they laugh. However, to me, this is the perfect scenario of why you shouldn't discount that legacy. Inside of that AS400 was a homegrown warehousing system, our homegrown EDI, electronic data interconnect system for how you order goods. It was basically the digital representation of Toyota's just-in-time continuous improvement supply chain solution. That's what made Toyota what they are today. How could you just scrap that, rip and replace it, and not instead modernize it, move it into a utility format that you could, if you wanted to replace the AS400, okay, that's a legacy piece of hardware. You can do that, but you do that slowly, methodically, fully understanding what's happening, and not at all impacting the business, instead supporting the business and allowing the business to be as agile, and pardon the pun, just in time as the business needs. So with that, we were able to very quickly, we did this whole project in just a little under 90 days. We were able to very quickly manipulate the scanners, manipulate the AS400s, and provide real-time, round-the-clock solution federated in cloud using Amazon's cloud for Toyota supply chain system.
Got it. So that's a case of lots and lots of legacy modernization, if you will. Let's skip up to another case here where we're talking about the integration of legacy and very modern things.
So this one I also find very entertaining, and the reason for that is, so we have a company we're working with, Parsable. Parsable is one of the most modern solvers of wearable visualization. So if you've got one of these watches on, or your cell phone or tablet, whatever you're using, Parsable is really good at representing data onto that device. Excellent. The problem is where would that data come from? In this case, that data comes from IBM's Maximo, which is a tool lifecycle management system. So picture this. You've got lots of people on a manufacturing floor, and they're walking around and they're looking at gauges on a dynamometer, or they're looking at the HMI readout that is on the front of a big KUKA swing arm, or on the front of a welding robot from Fanuc. Several of these robots may be 10, 15 years of age themselves, and the data may not be going anywhere anymore. The operating system for them, the PLC that's stuck on the bottom of them, may have been completely antiquated, and because of that, now the robot is in free form, working based on the fact that everybody's working around it, trying to make sure they don't get in its way because they don't know how it operates anymore. So people were manually doing data entry into Maximo's tool lifecycle management system. We built a bunch of forms that mimicked the paper, and we helped build the bridge between modern telephony, so cellular devices, modern tablet devices, wearables where stuff is going to be represented, but we built the bridge so that a worker on the plant floor wearing all of his safety, wearing all the PPE that's necessary now for the situation we all find ourselves in, they could still operate. They could take their hardened device, they could make sure that with their gloves and so forth, they were able to do the data entry as they stood in front of the robot, or even better, they could take pictures. We could interpret those pictures, and then we could populate the screens in the tool lifecycle management. What that allowed to do is now you have engineers who are sitting on the, as we affectionately call it, the carpeted floor instead of the manufacturing floor. Those engineers are waiting to find out whether their solutions to common problems or solutions to whatever they're doing, they're waiting to find out if things are working. And so in trying to resolve that, the minute the technician on the floor, the minute the operator on the floor enters into iPad, into Galaxy Tab, into iPhone, Android phone, whatever, the information or takes the right pictures, all of a sudden that as a sheet of entry, which before used to go on paper, is now available for everybody to see. So the minute it's available for everybody to see, now all of the engineers, all of the leadership that's trying to figure out where they are in product life cycle, all of the people that need to make decisions, that need to understand how best to operate the entire corporation, all of them can now make those decisions of themselves, pivot if need be very quickly, and can now operate the entire corporation with a minimum of loss, with an incredible minimization of safety issues, allowing for a lot more worker satisfaction, allowing for a lot more morale, because workers see the output of their actions. They, from what used to be a piece of paper that may end up, by the time it made it to an engineer's desk, having coffee stains and being part of some giant notebook that may have been turned over 5 months from now, now in almost real time, it becomes the product of collaboration, because now that engineer and that technician can communicate via the tool lifecycle, because the bridges are built in such a way that data is moving back and forth very quickly, and data is moving back and forth when that data is important. I'm very proud to say that our team was the organization that built those bridges, thus enabling that level of work to happen that much faster.
Got it. Hey, quick question here from Jim in our audience. What part of this implementation is in the cloud and what is on-premise?
So in this specific case, Maximo was in one cloud. Maximo was in Azure's cloud. The other side of it that represents the wearables, the parsable, and so forth, that was in Amazon's cloud. And our solution, the data mover, was directly on-premise at the customer. The reason for that, there was a lot of what they consider PII, what they consider personal information, what they consider their value-added knowledge information, what people call the keys to the kingdom. They didn't want that to be traversing outside of them. They wanted to make sure that they retained it, they had copies of it, and so we would also at the same time put it onto their premise. So they kept all the data. So if later on they chose to move IBM Maximo software to something else, they would have all the data. If they chose to move Parsable out of the picture, go to something else, again, they would have all the data. That data would be secured the way they wanted to. Their chief security officer made sure that he built a nice hardened support structure around it in their own data center. So in this case, it was 2 clouds and an on-prem.
Excellent. Hey, you've covered a lot of ground with these last 2 case studies and also lots of how-to and kind of procedural steps. How about we just take a few minutes to summarize, kind of, if you could just net it out to a few things. What would you recommend to the audience with regards to integrating and unlocking the value of legacy infrastructure?
So the biggest thing that I would recommend is the Kaizen, Agile, whatever you want to call the phenomenon. But huge IT replacements rarely work. And when they do finally work, they're 4 or 5 year projects having cost millions. And there is a lot of what we used to call dead bodies in the mix. So instead, small, bite-sized, 2-week sprints, very agile, very easy to be portable, and very easy to pivot to value. I would recommend moving in that fashion. I would also recommend that you always keep the value in front of you, demoing often, which also means bringing with you the organization that can really understand what the data means and that can understand in your demo that the value is for them. Meaning this isn't IT or this isn't technology working for the business, against the business, whatever. This is teams working together to derive corporate value as that value is necessary for the overall improvement or the overall betterment of the corporation. Lastly, pivot quickly, listen to the business. One of the things that I really like that always excites me, on the Toyota scenario, we ended up using truck drivers, we ended up using warehouse managers, because the most important part was synchronization of the warehouse, and because our platform is a no-code platform, we could allow those warehouse managers, those truck drivers that have never developed anything, we could allow them to help us draw the pictures that represented the logic that made the most sense to them. We could allow for that, and that itself turned into the code that drove the system. Now, not only did we have personal buy-in, we had their intellectual property captured because we are a no-code platform. Lastly, ask for help. Ask for help. We are here to help. There's lots of other organizations that are able to help. Like I said, when we first started with the Toyota system, I walked up to the board and drew a bunch of stuff and waited for the first truck driver to tell me I didn't know what the hell I was talking about, which I said, okay, I appreciate that. Please come help me. That truck driver laid out for me what a truck route looked like, what it was like to pull into the bay, the fact that he had to be in and out every 28 minutes, what a manifest was, how things got scanned, where his badge went. From that, we were very quickly able to gain all the data points that needed to be captured, how they were going to be captured, where they were going to be transferred to, and how everything was going to get reposed.
So clearly asking for help means calling Dimitri. But as you guys might have known about HULFT, we have 10,000 worldwide implementations over our history with integrating all kinds of legacy assets with all kinds of modern. That's just what we do. We have lots of case studies and lots of materials on our website. So you can hit our website and find videos and collateral. With the last couple minutes that we have, I wanted to address 2 more questions that we had from our audience, Dimitri. One question is, what do you do with mechanical equipment that's nearly impossible to digitize?
So funny you ask. So we've got the opportunity to put our no-code platform onto something as small as a Raspberry Pi. So with that, we could mimic the likes of a PLC. We could almost make the equivalent of a digital bridge for a mechanical system. We've done this in the past. We've got an example that uses electronic sensors, electronic relays to turn on and off a light bulb, to turn on and off devices, and that then gets to operate through the Raspberry Pi into the modern digital world. So just as a PLC controls mechanical and electrical connectivity, we can make that Raspberry Pi into a hardened PLC using HULFT to integrate. So we can put that into the rest of the communication path and make it just as modern as most things today.
Okay, got it. And final question. Let's make this a yes or a no question, just so we can wrap. One of the audience people said, I have a 30-year-old AS400, and I've been told it's impossible to integrate it with the most modern stuff. True or false? Yes or no?
Hell no.
An AS400
you
can be
can integrate it. Yes, you can integrate it into anything you want. We can help you do it. It's really not hard. Excellent.
Thanks, Dimitri. So, as I told you before, this is the HULFT Digital Transformation webinar series. We just covered the legacy infrastructure section. And on demand, we have everything in the past. So you can, and then next week, we've got why most RPA projects fail. So we'd love it if you would join us for that. But anyway, you can look forward to an email from us following up on the session, sending you a recording of it. And from there, you can connect with Dimitri with all of your needs. Thanks a lot, and thanks for joining today.
Thanks for letting me speak. Good talking, everybody.
All right.
Take care.
Have a good rest of the week.
You too. Take care, Kurt. Bye-bye.